All right, it's been a while, but time to get back to it. Time to get back to creating a game. So where was it that we left off? So we have a game that starts up and that has some input and that has some initial rotation of the pieces, but it looks a bit funky. So there's probably some work to be done getting this right. And then when the pieces are being rotated just fine, like when the inputs are being handled properly and we're reacting to them properly, then what we can do next is implement the actual gameplay. So a single game mode to start with, and then combine everything to enable multiplayer. We already have matchmaking from GameKit, but we will need to route input remotely through one host. So figure out rotating pieces, implement gameplay, single game mode to start with, and then adding multiplayer later. And then we're done. So that's going to be a long time from now. So that's not the plan for today. The plan for today is to figure out why the pieces are rotating so oddly, and ideally fixing that and adding more pieces. So not just this L-shaped one, but something more. And so let's see why the pieces are not rotating properly. So what we are doing right now is we're loading this L piece from this scene editor and using it as a template. And then we actually, because this is offset and this can be moved around in the scene, we actually grab the root and then add this to the scene. So the one I was rotating here, this piece is a copy, a duplicate of this root scene that I have in the editor in Xcode. And probably one of the reasons why it's rotating oddly is that it's offset. So here it's not centered. So it's going to be rotated incorrectly. So let's move it back. There's really no reason for this root piece to be offset. And it's probably not the only issue, but let's see if this changes anything at all. It still looks a bit funky. It's hard to judge, to be honest. All right, that is definitely a bug. It should have stopped. So what it should have done is it should have stopped when it hit the red base, and then it should have probably tilted and fallen over. And then at that point also it should stop receiving input. But all right, we'll get to that. But it still feels as if it's being rotated around something, but not quite the center. Interesting. There are multiple nodes actually here. There are multiple, yeah. So we are rotating around the center of this left side of the piece. So this is the origin point. But why is that bad? It's hard to reason about this because I'm not used to this. So the origin point should be somewhere, like it should be something like this, right? And then we can rotate around it. But if we have it here, well, suffice to say that it's skewed a bit. So what we want to do is, I think what we want to do is actually be precise with the sizes, and then we can know exactly where to put the origin point. So we're not being precise with sizes. The overall texture node size is 147.175 points horizontally, and this is just a mess. Ideally, we want to have one kind of unit. We want to set grid size, and then we want to reason in those units. So probably something like, if we want this size for this for the piece relative to the scene, then probably what we would want is for the size to be 150, and one grid size. The width of a grid column should be half of that, because the L piece has two columns. It has the leftmost column and then like the little nook on the rightmost column. So it should be 150. But I cannot change this directly because it does not change the height proportionally. All right, it's gonna be fun. Using this. All right. So let's take a look in the assets, in the L piece. What is the size of this image? I'm trying to open the image in Finder right now, but you cannot see that. But I'm looking at this at the dimensions, and the dimensions are 614 times 917. Times 917, which is not, to be honest, which is not great. So I have not prepared the texture well. It would be easier to reason about it if the texture was already like in exact, more exact sizes maybe, but it's fine. Is it fine? Okay, if I could do some math and see what the ratios should be given this input size, but then down the line I will want to add actual proper graphics to the game, and then those images will need either different ratios, or ideally I would set these placeholder images up in such a fashion that down the line it's very easy to reason about how to represent them in the game. I map them to the grid. So these sizes are actually not good. We don't want to have we don't want to reason about like how to go from 614 on a retina screen to a column of width 50. So I guess I need to redo the image, but I don't want to redraw it, so maybe I'll just try and mess with it in Finder, in Preview. Preview, what a great tool. All right, let's try this. So I don't really know how to use Preview, but it has an adjust size thing. All right. The actual ratios of the piece are fine because its height is 1.5 of its width. So actually, maybe I can, if this ratio is preserved by future textures, then it doesn't really matter what the size is. I could resize the image when I load it, or when I load the template piece. I could adjust the node manually. I might actually need to create the node template manually and not design it in the the SpriteKit editor, because the collision boundaries also need to be very precise. The collision boundaries need to be tight, because if I do them by hand and I accidentally make them 2 points wider, then all the collision is going to be messed up immediately. All right, so I think what I will do is I'm going to revisit the place where I load this template, and I'm going to recreate it in code. I'm not going to load it, but first I want to know if I can somehow visualize the physics bodies, because it could be very, very helpful to actually see if I'm creating them correctly. So let's start coding today by going to the gameplay scene, and let's see here, scene, did we have anything here? Scene dot show physics debug, no, maybe it's on the view, debug, no, show, here we go. So on the view, show FPS, show fields. We want to show fields. The field is what causes the piece to go down, and it's not gravity, but it's just a simple field because we want a constant acceleration, not acceleration, but a constant velocity. So I'm using a field, and the gravity is actually set to 0. And we want to show physics. And let's see what changes now. All right, press a key. Nothing changes. I cannot see a single change. Why not? This is interesting. Oh, of course, because I'm a dummy. Here I set the views show fields to true and show physics to true, but there's no view here because the scene did not move to a view. The scene moves to a view here in scene did move method. So let's do it here, and then just in that same place we actually create the template, which is great because we can just stay in there. All right, so actually this is great. We can see that the physics bodies are not right. Oh, and it's moving. Yeah, this is messed up. And when we rotate, it just, of course. Yeah, now like seeing this really makes sense because I just put 2 physics bodies, but I never connected them in a way where it's a single body, right? So one body stops, but the other body keeps sliding down, and then we rotate the parent piece, so they both kind of, it's a mess. It's a Frankenstein type situation we have going here. But okay, first step is to understand this issue, and then we can know what to do about it. So here where we want to do the create the template, we're not going to load the template from the scene, from the pieces scene. Let's remove this actually completely. LP's template, boom, done. It's not there. Spawn point we can load from this actual scene. Okay, let's say create LP's template, and we will probably refactor this method later, but for now it's fine. For now, it's just a simple thing. Return let's return a sprite node with a color blue and a size. And the size that we want is actually, so if the column is 75, then the size is width 150, and height is 1.5. That is 225. All right, and there's a capitalization issue here. And now, what is happening with this? Oh, that's a big node we just created. So maybe 50 was not right. 50 was, I had messed something up there. How is 50 this big? I mean, how is this width 150, right? So if we look at the pieces seen that we had designed here, then the texture node's width is 150. So why is this better? Why is this not humongous? Anchor point, middle, scale. Does the scale affect? No, like the width takes the scale into account. This is odd. I would have expected the size to match. Okay, maybe I'm misunderstanding something, but it doesn't really matter because we can just go back, and since we're going to do this in code, we can just adjust and we can say, okay, this is too big. Let's try, maybe let's try with grid size 30. So if the grid size is 30, then width is grid size times 2 and height is grid size times 3. Let's try this. And this seems like a plausible start. All right, so now we want a physics body on this. How do we create a physics body? The class is physics body, and we probably need a physics joint later, like for the, that's probably what I was missing for the previous two physics bodies, like a fixed joint that fuses two physics bodies together at a reference point. That's exactly what I was missing. But anyway, so we're going to create a physics body, and we can create two bodies and fuse them with a joint, or maybe we can just use a path, edge, actual polygon. We could create a path. Probably simpler to not do a path. Like might be simpler from a computational point of view as well. Like it's a path seems complicated, and we just need two boxes to be honest. We need two boxes and fuse them together. So let's try a rectangle of. So this is so let's say left rectangle is left size is times 3. This is the left rectangle, and the right rectangle is with grid size, and height is also grid size, but it's going to be at the bottom. Now left body is this, right body is the same but with a different size. Now we have two bodies and we need to fuse them together. And how do we do the joints? So let's try and take a look at the documentation. SK physics joint. All right, Apple, what do you have for us? A physics joint object connects two physics bodies so that they are simulated together. You never instantiate objects of this class directly. You create one of the subclass. Okay, connecting bodies with joints. Here's this. This seems like the guide that we need. Fixed joint is the one we need. How do we do this? Create two physics bodies, attach the physics bodies to a pair of node objects. All right, I haven't actually attached. Okay, well, let's do this. So we have two physics bodies. Perfect. Now we need two nodes. So we're gonna change the base and we're gonna have a left node and a right node. Left node. And we can reuse the sizes. How good is this? This is code reuse at its finest. All right, left node, right node. Oh, right node. Left body, right body. And now create a joint object using one of the types shown above. All right, so we don't go through the bodies, we go through the joint. Is all right, so physics joint fixed with body A. Oh, actually we need to add the bodies to the nodes. Physics body is left body, right node, physics body is right body. And now fixed joint with body A, left body, with body B, right body, and anchor is, what is the anchor? Oh, I've been talking about my amazing code reuse, but showing the Safari window all the time. Oh, this is great. This is amazing. This is exactly what I intended to do. All right, but back to Safari. Physics joint fixed. Creates a new fixed joint. Cool, cool, cool. So anchor point for the connection in the scenes coordinate system. What? The scenes? And the body must be connected to a node that is already part of the scenes node tree. All right, interesting. You must add the joint to physics world associated with the scene before it takes effect. Okay, that part is fine. But when I create the joint, why does the body must be connected to a node? Why does the node need to be part of the scene already? Because I want to have a template. Can we have a template? Oh, come on, Google. Physics joint, why part of not part of scenes tree. All right, let's take a look at the joints again. When you create a joint, the points that connect the joint are always specified in the scene's coordinate system. This may require you to first convert from node coordinates to scene coordinates before creating the joint. All right, I don't know enough about how physics engines work to understand why why this has to happen at the scene level, but it looks, from reading the docs, it looks that I cannot simply say connect these two physics bodies together at this one place on the template before we add it to the scene. We could do this when we actually instantiate the instantiate the node. It's not a huge deal, I guess. Or we could just use the path maybe as a interesting. How do we choose? How do we choose what to do? We could use CGPath, or we could join the node at the point where it's inserted into the scene. And for now, we just have one node, one base node with two children that both have bodies. Well, let's try out. Let's see what that looks like. So let's create an empty node. This is going to be the root. And then base is going to have add child left node, and then base is going to have add child right node. And left node position is going to be, so we want to move it like half. Like by default, it's going to be in the middle, in the center, and we want to move it half a grid column left. And then we want to move the other one half a grid size to the right. So grid size divided by 0 and vertically. So the left size is fine vertically. Because it already spans the full height. This needs to be a minus. Right node position has to be shifted to the right, but this also needs to be shifted down a full grid size. So we have, so this is the grid. The grid looks like this. Oh, again, I'm not sharing what I'm doing. Yeah, so here we are. So the grid looks like this. Autocomplete is trying to mess with me. So this is the grid. And the left node is this. Let's call it L. And the right one, when we shift it right, it's going to be here in the middle by default, because that's the center of the node. So we want to shift it down, and the coordinate system of SpriteKit goes from bottom to up, like in math class. So we want to do minus grid size, I think. Minus grid size. Well, let's try. Let's see what this creates. Let's see what we have cooked up. Yeah, that's exactly what I was going for. But now, probably when, yeah, so when it hits, it's fine. But when we rotate, because there's no joint, it's gonna fall apart. Yeah. Ooh, it broke so well. Yes. Beautiful. Okay. So far, so good. So some things that we probably need to change is we set the friction previously in the editor, and we set the not the friction, but oh, we set it to be fixed so it cannot rotate. So you can see that the small box when it fell apart, like it's rotated a bit. It's probably not super visible, but it's like it's not completely horizontal because it's being rotated, and we actually don't want it to be rotated. We want it to be stuck at the initial angle. And then we will allow rotation afterwards when it actually does hit the ground, but initially it's going to be like this. So now we rotate, and yeah. So we can rotate it, but the physics engine will not rotate the pieces. So the end result is much different now. Okay, cool. Now we need to glue them together, and we also almost have our thing. And the good thing is we have a grid size, and we will probably need to move this out of here so that other pieces can use this well. Like this is going to be a central thing, right? Like the grid size is not something we want to just keep in like a small LPs template method, but for now it's fine. So the question now is, how do we glue it together? We will need to extract the left body and the right body, and actually to do that we probably need our own class, LPiece. Let's say we want an LPiece. It takes a grid size, and then let's do everything we did there inside here. But now we can keep track of the physics bodies, LPiece, left body, right body. We can keep track of the bodies. Yeah, that's the thing we need. All right. And we need a root node, but actually we don't need a root node because we are ourselves the root node now. Oh, and there's a required initializer, that's fine. We're not going to use, we're not going to allow this to be instantiated from the editor, so it's fine. I guess that would be this would be the initializer needed to load the node from the editor, from like an SKS file, but we're just gonna do this the old-fashioned way in code because we want the collision bodies to be very precise, very specific, in very like set places. So now here, create LPiece template. We actually don't need to create a template because we moved the template into an actual node. So here we can just say let create an LPiece with a grid size of 30. So we lost the grid size like as a static thing. And we don't even need to do anything. Let's hear like the code becomes simpler. There's no LPiece template anymore. Let's remove it. Now we will be able to do what? We will be able to join the pieces because we will be keeping track of the bodies. Okay, so that's our brand new LPiece node falling down. And when we spawn it, we want to set the position, and we want to join it, but to join it we need to ensure that the piece has been added to the scene. So we should create a method that combines adding it with doing the joins. So it's a bit, we're imposing some constraints on how this node can be used. And 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 basically we're saying that this method should be only called by us, so that we know exactly when. No, actually, we don't care. Okay, maybe the node knows when it's added. Add observer, no. Parent. Move. Remove from parent. Did move to parent. Let's see if this is called at any point in our node's life. Because we add the child. We add the child. We add the LPs as a child node to a spawn point, and this move method never gets called, unfortunately. Okay, let's go to Safari and let's Google a bit. Okay, node. No when added to a parent. Oh, but actually, if we add this to a parent, we don't really know if it's added to the scene. It's not the same thing. All right, let's not complicate this. Let's keep this simple and create a method. And we're going to say, add to spawn point. We're going to do this. No, actually, even better, even better. So this is going to be a private initializer. And we are going to have a class function saying spawn at spawn point node. And now we can check if spawn point scene. And if we try to spawn the node without it being added to a scene, we're just going to say, this is impossible, we're going to crash, we're going to die, we're going to blow up. Only spawn this node. Spawn point not added to a scene. So basically what we want to do, we want to be able to spawn this only in in an existing scene, so that we know for sure we are being added to a scene because we add it ourselves, and then we can do the joining thing. Okay, I hope this makes sense. Probably doesn't make as much sense when you're listening to it, but in my mind, I have glorious purpose. So grid size, well, let's say grid size is not something we want to pass in. Let's keep grid size from here. And let's do this. Oh, and this should actually return a node, but it's gonna return it just as an SK node because we're not sure yet. I'm not sure yet that we actually want to expose, like to propagate this node information later down the road. Like we don't need that. LP spawn at spawn point. If spawn point is spawn point, so the let statement came back, and now we can spawn it. Now we can say, we can move this part here. We can say, you know, L piece is L piece with grid size. The position is this, and we return the L piece. But we also say spawn point add child, which is the L piece. And now the best part is, we have a place to do the physics body joins. So now here, everything is added to the scene, and we can join physics bodies. So let's try again. Joint fixed. Joint with body A, and this is L piece. Left body with body B, which is left piece, right body. And the anchor should be the center of the node in scene's coordinates, which is actually the spawn point, because we are adding the L piece at position, like the position 0, we're adding it to the spawn point. Can we just say use the spawn point? I think we can. Let's try. So join anchor scene convert point. How do we convert points? Spawn point convert. We want to convert to the scene. So let's go to Safari again and let's Google how to convert. SpriteKit convert node point to scene point. Converting coordinate spaces. That's what I meant. Position in scene is convert. Okay, so we need to call this convert method on scene. Convert position from parent. Okay, so scene convert. We want to convert the center point, the origin point from spawn point, I think. And now that is the join anchor, I think. Maybe. And what do we do then? What do we do with the result? Okay, so now we need to retrieve the scene's physics world object and add the joint. All right, perfect. Let's go back to Xcode. So now we have a joint, scene, physics world, add, joint. All right, so how does this work? What have we done? Ooh, this is not at all what I had in mind, but it's almost good. There is some kind of joining happening. It's just not right, but it's there. So what happens if we allow rotation? Is this because we disallow rotation? Yeah, so if we allow rotation, then these bad boys are rotating together. But it's not amazing. Like it feels weird. Okay, but we definitely don't want to allow rotation, but we want them to rotate together. So what are we missing? It's a fixed joint. Maybe the anchor point is wrong. Why is it only rotating one of these? And why is... It's interesting. So I think the way this is drawn, it goes from the center of the left node to the center of the right node through the anchor point. So the anchor point was correct when we added the node, but for some reason the rotation is messed up. Something's weird happening here. when we rotate the node, what do we actually do? It looks like we are not. So let's take a look at how we rotate the node. I don't remember what I did there, but I think it was in the player, like I made a player controller class, and this is the part that binds to a player and a piece, and here we grab the first child of the piece and then we rotate that, which could explain it. That's not what we want to do anymore. So this was happened with the template, because in the template the root was something that was offset and moved around and had like a funky anchor point. But now we don't want to do that anymore. Oh, so now we want to process input, and we have a piece. Let's just rotate the piece strictly. Yeah, there we go. So bad. All right, so there's something not good happening with the anchor points. Yeah. So we keep rotating, I think, around the spawn point. Like what are we rotating around? So the piece is falling. The piece is not falling. Okay, so I remember what was the issue. So we have a root node. And the root node has two children. And the children are falling, but the root node is not moving. It's only the children that are moving around. So when we rotate, there's a phantom node. Actually, I think I can illustrate what is happening here. Let's go back to this. And let's say that, let's add like a very simple node. That's like a sprite node, color, system teal, left size. Let's do this. It's a very simple thing. So we have now multiple children. And so this is what's happening. The children with the physics bodies are falling, but actually the node itself, it's still at the top. And if we rotate the node, then it rotates just fine. But the child of the node is long gone. So the anchor point for the node should actually be the center of wherever the two children end up. Oh, this is not good. Okay, so how are you supposed to handle this? I don't really know. Let's go back and let's see. SpriteKit, move parent node with child physics body. Have parent node. Now I think, all right, this is the topic actually. Let's take a look. No, it's not the thing. The parent has children's physics bodies. I think what I'm gonna do is I'm gonna go back to Xcode and I'm gonna ditch this two-box solution, and I'm gonna try and create a CGPath and just have a single body. And I think it's the right thing to do, because one thing that you can also notice if you look closely at the at this basically, one thing you can notice is that from all of this moving, despite there being a joint, the rightmost box has kind of drifted on top of the leftmost box. So it's not, so the two physics bodies are not perfectly like stuck together or fused, but they can kind of move sometimes, and it might introduce some discrepancies later. And so if I just go with a CGPath, it's going to be simpler, and it's definitely not going to be deformed. So it's like it's going to maintain its shape, which is a guarantee that I would quite like. So let's take a look at how a CGPath can be created. I don't want a mutable path, but also let's CGPath create Swift. Okay, cool. No, this is not it. UI path. This seems like an iOS only class. Is it an iOS only class? It absolutely is. Let's search for a cross-platform UI Bezier path. We could do some ifs and thens, depending on NS Bezier path and UI Bezier path. Path with components. Now this is a string. What is a path? Just a path class. Oh, this is Swift UI. No, this is not. We want Swift UI is great, but it would be great if we could have a native path type that's not bound to Swift UI. Is there a way to use something? All right, this sucks a bit. So we don't have a cross-platform way to draw paths. This is unfortunate, but well, let's just start with an as Bezier path, I guess. If OS, macOS, is there a macro for errors actually? Yeah, there is. All right, cool. And this is their path. And we want to move to, where do we want to move? We want to move, we're at the center and we want to move left. Right, so we want to move left to the far edge, so minus grid size, and let's start from like a simple place. Let's go to left and to the bottom, so minus grid size, and then minus grid size. Okay, so there are three, imagine the grid size being like 3 boxes in height, and so we need to move 1 box left, and then we need to move down 1 full box and 1 half a box, and it's this, to be completely sure, but it's just, now we need to cast it. And now something is still missing. What is missing? Cannot convert value of type int. Yes, so. Come on, Swift. What are you doing? I don't understand what's happening here. Cannot convert value of type int to double. Where is this the double? Move left is grid size, move down is now left. So what don't you like? What is the separator you are missing? All right, I'm missing a closing parentheses. Yes. So that's what I was missing. I was not missing a comma separator. I was missing a closing parentheses. Thank you, Swift, for that useless error message. But this is, of course, mostly on me, because obviously I was missing a closing parentheses. Okay, so now we are at the bottom left of the node. So now path add line. Yeah, now we do lines. Now we're gonna do a line to leftmost, bottommost. Let's rename this. Because we are moving to absolute places. And now we are moving still, we keep moving from leftmost to topmost. So topmost is the same as bottommost, but we flip the sign again. And rightmost, middle is 0. And then after middle, what is it that we go to? What other points do we need? Bottom third, let's call it. It's bottommost. But we add grid size. All right, and now let's see what we can do with this. So we go from bottom left to top left to middle, top middle. Then we stay on the middle, but vertically we go down to bottom third. Then we go to the rightmost. And rightmost is same as leftmost. But again, we flip the sign. So we go to rightmost, bottom third, then we go to rightmost, bottommost, and then we close the loop. Do we need to do close, or can we? Well, I think we can just close and go back. Maybe, maybe not. Let's see. So we are at the rightmost, bottommost, and it's either close or it's line back to the starting point. And now we have the body path that we want to set. Body path is path.CGPath. No. How do we create this? How do we do this? Create. All right, let's go to Safari. Oh, none of what I've been doing was actually, my bad. All right, let's go back to Safari that I actually never ever left. And let's take a look at what's happening here. NSPath to CGPath is what we want to know how to do. Stack Overflow, right from Apple documentation. Oh, wow. Oh, we need to. Ooh. I hate this. Like, this is not a path. This is not an amazing API. Like, this is not an API that I love to use. I mean, this comment sums up Apple's documentation. Why, like, not even documentation, but just like, I don't know, like developer care. They have a method to convert busier path to CGPath, and they put that in the docs. I mean, it's good that it's in the docs, but it's a shitty method. Like, it should be something simpler. And like on iOS, you can get the path directly. Poor macOS and its APIs that get no love. I'm just gonna shamelessly copy this extension, and because I don't really want to be coding path conversions. This is like, I don't think it's fun. Let's try this. All right, let's see. And now, none of this is actually relevant. But what is relevant is set the physics body directly on the node. Polygon front path, body path. And we don't need to initialize these anymore because we're not using these anymore. All right. And so spawning is also much simpler. We just add the chat. To be honest, we don't even need this whole spawning method anymore, but for now it's fine. Let's see. All right, signed in. Here we go. What a great path. And it is rotating so well. Amazing. Boom, and it fell over when it hit the ground. It's perfect because I forgot to set that it cannot rotate. So we will allow it to rotate when it hits the ground, but initially it should not rotate. It should only rotate when it hits. Or actually, maybe it's fine if it rotates, right? Because what we want to do is not to prevent it from rotating. What we want to do is when it hits something, we want to prevent it from getting further input. And that is fine. So, let's try this again. Here we move it. It's rotating relative to where it is. The problem is that now I cannot rotate it anymore as I wanted to. Come on, come on, come on, come on. Ah, boom. That's what I wanted to do. And now. Okay, this is a bit skewed. This is not exactly like the base does not really honor the grid, I think, currently. It's fine. Boom. What an amazing send-off for the first piece that is actually rotating like we want it to rotate. The problem here is that it is not a textured piece. So what we actually want to do is we want... Oh my god, I keep forgetting to switch back the scene. So you didn't see any of that. Well, let me do this again. So actually, let me show you so this was the path that I created. So we moved to the leftmost, bottommost point, and then we kind of go around the entire shape. So we move to the top, still on the leftmost, then we move to the middle at the top. Then we stay in the middle, we go down to the bottom third. Then we go to the right and do like the little like nook, and then we close the path. And if we run this, then what we get is this. It's not textured, but you see that it's rotating around the node. It's doing it what it's supposed to, and when it stops, it doesn't fall over like this. Yeah, it's fine. It's good. We will figure out the actual physics later, but for now, rotating, it's fine. The size seems like a plausible size for the scene, so the grid size that we've arrived at by trial and error, well, not by trial and error, by a single guess, 30 points, that's probably fine. And we can rotate it, and it's moving, and everything is good in the world. But what we need to do is add the texture now. And since I'm creating this piece by code, I'm not completely sure how to get the asset image. So it's called the L piece, and it's for some reason I've put it in the backgrounds, but it's not in the backgrounds actually. It's something. Okay. folder. It's a folder. What I want to say is pieces. And now LPs. How do I load it? Well, let's see. First, let's go back to the scene. And I think the first thing is that we want to inherit from a sprite node instead. And now when we create ourselves, we want to have an image named, well, let's try image named LPs. Like, does this work? Must call a designated initializer. Okay, I guess this is not the designated initializer. Why is this not the, okay. I don't really understand why it's saying this. It's probably something obvious if you know how to use Swift. Must call designated initializer. I kind of get the idea, but I'm not sure why this would not be the designated initializer. So required. No, this does not help. Swift designated initializer. What is the designated initializer? Primary initializer. Designated initializers must always delegate up. All right, so I'm in a subclass. How do I know which one is the designated initializer? All right, I'm gonna take a very short break and be right back to continue this amazing investigative journalism type thing. Just a sec. All right, I am back, having made my Apple Watch happy that I'm not just sitting around all day looking at their documentation. Now, let's see, what is a designated initializer? No, we actually don't care about that. We want to know what is the designated initializer for SK_Sprite node. And there is exactly a question about exactly this on Stack Overflow. The only designated initializer is this. So init, texture, color, and size. But can I just call like sideways? Does that? Oh, this is this is not great. This makes subclassing the thing a bit harder. Oh, but we can. All right, so somebody has done. Okay, so we say that this is a convenience initializer, and is that going to help us? So this is a convenience initializer. We need to knit sideways now. This is interesting. I don't understand how this works. So they made it work somehow by creating a simple convenience initializer. Okay, so this is a convenience initializer now. And now I need to call initializers, but I don't have access to the image named initializer. So this is actually from the year 14, so maybe this is outdated. Let's Google something else. Maybe there's something easier. Yeah, okay, something newer at least. So there's something from 2017. Let's see if we can if we can reuse whatever happened here. So just change your convenience initializer to this. All right, so this kind of is recreating. So this is recreating the image name thing, but actually it's fine. This is what we really cared about: how to get the texture, from the name. So let's go back. Let's make this an actual initializer, not a convenience initializer. And now this is the initializer that we want. Texture is piece. Texture size. And what was the, I forgot what was the dedicated initializer. The designated initializer for SK_Sprite node is color. Oh, it has color as well. Color. Color white. I guess we can grab white. Doesn't matter. NS color. This like so messy. Native color white. Let's do type alias. Type alias not sure if this actually works in every use case, but it helps in some simple use cases at least. So now what happens? Yeah, so good. So no, but this is actually fine. So it means we can load the image, and now we can actually calculate the size that we want for the image, right? So the target size, well, let's try. So the target size is width grid size times 2 and height grid size times 3. There's a typo, grid size like this. And now target size we give here. So I'm doing this just to see if it already scales it or if it's going to just grab that sized chunk from the image. No, it's perfect. It's exactly what we need. Okay. And now we have a path. We have the ability to load images regardless of their size, as long as the image has the right ratios, right dimension ratios. We create the path. The paths don't drift as they might have with the disjoint 2-box solution I tried initially. Okay, so this is pretty good. This seems like a good checkpoint actually. So what do we need going further? What do we need going further? We need, let me just remove this old, like these comments. Okay, so going further, we need to add more pieces. And then when a piece hits something, it immediately needs to stop receiving input, and then we give that input to the next active piece that gets spawned. And then we might need to tweak some of the reactions, but not reactions, but like interactions with the environment. So how fast it goes down, is there any like bounce when it hits something or not? How quickly it rotates, like stuff like that probably will need to be tweaked, but it's not very important for the core gameplay progress. So actually no, we don't care about that right now. So those will be tweaks that we can add later. We need to add more pieces, and then we can start work on the initial game mode. So I'm gonna hit end on the stream now, and then I'm gonna go drink a tea and consider the next steps. And then when I return, I'm going to do, well, actually I'm gonna do the planning live a bit later. So actually I'm just gonna hit pause, take a little break, have some tea, maybe go for a walk, and regroup later and continue this. All right, so far so good.